Hey everyone, welcome to the very first episode of our exciting new book series Hands on Machine Learning with Scikit-Learn, Keras, and Tensorflow. Today we are diving into Chapter 1 The Machine Learning Landscape. Whether you are a complete beginner or looking to sharpen your skills, this series will guide you step by step through the world of machine learning with hands on examples. So think of this chapter as a high level introduction to the world of machine learning. There won't be much code here, just key concepts that every data scientist should know. It's like learning the rule of a game before you start playing. So grab your coffee, get comfortable, and let's explore the fascinating world of ML together. Let's get started. So when most people think of machine learning, they often imagine a sci-fi robot, either a helpful assistant like a robotic butler or a terrifying machine learning terminator. So, but machine learning is not some futuristic dream. So back in 1990, so spam filter quietly revolution email. So they learned how to block junk mail so effectively that most of us barely even notice their work today. So maybe the sound as excited, not much as excited as a self-aware robot, but this humble spam filter is a classic example of machine learning in action. So what is a machine learning? So according to the Arthur Samuel, machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. And via the Tom Michel in engineering way, a computer program is set to learn from experience with respect to some task and some performance measure if its performance on as measured by P improves with experience. Okay. So I give you one more simple definition of machine learning. So machine learning is a way to teach computers how to learn from data instead of programming them with fixed rule. So I give you an example like imagine you are teaching a child how to recognize spam emails. Okay, so you start by showing the child examples of spam messages and regular ones. So over time, the child learns to notice patterns in spam mails, like certain phrases or suspicious links without you directly telling them the rules. So this process of learning by example is what machine learning is all about. So I also tell you a story. So let's say you have a really smart assistant named Alex. Okay, so you want Alex to help sort your emails into two piles. One is spam and another one is important mail. So at first, Alex doesn't know how to tell the difference. So what you do? So you show Alex a bunch of emails. So you have already sorted. So Alex saw these emails and these examples are Alex training set. Okay, so and the each training example is called a training instance or sample. Okay, so so over time Alex gets better at figure out what makes an email spam and like seeing phrase such as a bin free and a iPhone or weird email address. So like this, so now Alex task is to flag new emails as a spam or not. So the experience of Alex is all the emails you showed as examples. So To check how well Alex is doing, you measure how many emails were correctly sorted into the right pile. So this is the performance measure. Okay, this is the performance measure, often called accuracy. So if what you check, so if Alex correctly sort 90s out of 100 emails, so that's a 90% accuracy. So it's pretty good, right? So over time, Alex gets better as you give more example, improving with experience just like a human. So machine learning is like teaching your computer to be a really good student who learns by doing. And so why we are using a machine learning? So imagine you are running a post office and you want to sort letters into two piles, spam mails and important mails. So you could try write down all the rules yourself to identify spams, but this would be exhausting and never ending process. So and let's break down to understand why machine learning makes life so much easier compared to traditional method. So what is the old rule? So at first you notice some spam letters often used, but like free for you, credit card, Amazon, and limited offer, bin. So you write rules like so if the letter mention free, so mark it as a spam. So yeah, and if the letter comes from a weird sender, so mark it as a spam, etc. So you create more and more based on pattern you observe. Okay, so but soon the rules become so many and it's hard to manage. So every time spammer is hard to manage. So every time spammer changes tactics like using for you instead of for you. Okay, so you have to rewrite the rules and catch them. So it's trying to plug holes into a sinking ship. This is a traditional approach and it's complicated and time consuming. So what is the smart way? So letting the machine learn. Now imagine you have a super smart assistant who who watch how you classify images. Okay, so you show them lots of examples. You said show them lots of examples, and mm, you show lots of examples of spam and non-spam. So they start noticing the pattern. Okay, so much more complex one than you did. So for instance, your assistant learned that spam often has certain words, formats, or even suspicious sender details. Okay, so next time, so even better that this assistant keeps learning. If spammer starting writing for you, okay, instead of for you, so the assistant quickly picks up on it without you having a lift a finger. Okay, this is the machine learning approach, and uh, and uh, it learns directly from the data and adapts at pattern changes. Okay, so now we are talking about the uh, now recognize spoken word. So you might notice that the one and two. So notice that the two start with a high pitch. So you could hard code an algorithm that measure high pitch sound intensely and use that discarding once and So so you could create rules like if the sound start high pitch, it's probably the world too. But guess what? This doesn't work when millions of people say word differently in noisy environment or a different language. Just like I say to in a different way, you say to in different way, and other person say in different way. So so writing the rules for this would be impossible. So instead, machine learning steps by giving it lots of recording labels, one or two, the computer figure out how to recognize these birds even with background noise or accent. Okay, so so the machine learning does not just just help solving problem. It can help human learns too. For example, if a spam filter tells you which word are the strongest prediction of spam, okay, so spam, you might discover something surprising like unsubscribe being a common spam word. This kind of is insight where machine reveal hidden pattern, and this is called a data mining. Okay, so when you find the hidden pattern, that time it's called a data mining. So why machine learning is awesome? So it save the time and effort, okay? Solve the complex problem, finding hidden pattern. So in the short, we can say machine learning is like hiring a brilliant, tireless assistant who not only does the job better but also get smarter over time. Even teaches you something new along the way. So now, so how many types of machine learning? So machine learning systems comes in all shape, okay, and shape and size. So it's help group them into categories to understand how they work. So think of these categories like different approaches or strategies that machine can use to learn. So how much human guidance needed? So some system needs teacher to guide them, okay? So while other learn by exploring or their own. So these are supervised learning, unsupervised learning, semi-supervised, and reinforcement learning. Okay, so some system learn all at once, okay, or while other adopts on the fly. So it's like online versus batch learning. And when faced with new information, system use one of two strategy. So it's instance based versus model based learning. Okay. So yeah, so these category are not rigid. Okay. So you can mix and match them. For example, a cutting edge spam filter. So learning continuous from new emails, online learning. Okay, so let's look at each of these criteria a bit more closely. So let's talk about supervised learning. So in supervised learning, the training data you feed to the algorithm include the desired solution card labels. So I give you an example. Think a teacher's guidance. Imagine you are learning to recognize types of flowers. So a teacher's gives you a bunch of labeled flashcard and each showing a picture of a flower along with its name like rose or tulip. So over time you start recognizing patterns like roses often have a specific petal shape. So that's what supervised learning is. The system is fed data, okay, with answer labels and learn to make prediction based on them. So for example, a spam filter learns to label emails as spam or not spam by analyzing pattern in previous labeled emails. And a car price predictor learns from example of cars with details like mileage, age, and brand input and their prices labels. So supervised learning handles two main tasks. One is classification and other one is regression. So classification, so sorting things into categories like labeling email as spam or ham, and regression, predicting continuous values like estimate a car price based on its feature. So it's like being a student who learn with lots of clear example and answer. Is and In this book we are learning some important supervised algorithm like k nearest neighbors, linear regression, logistic regression, SVM, decision tree and random forest and neural networks. And What is unsupervised learning? So in unsupervised learning, as you might guess, the training data is unlabeled and the system tries to learn without a teacher. So I give you an example like think imagine you are a handled a pile of data with no instruction, no labels, no hint, just raw information. So your job is to make sense of its uncovering hidden pattern or relationship, much like solving a mystery without a map. So in this book we are learning some unsupervised algorithm like clustering k means clustering algorithm k means db scan sca anomaly detection and novelty detection, one class SVM, isolation forest for visualization and dimensionality reduction, PCA, kernel PCA, LLE, TSNE, associate rule learning, a priori and ACLED. So, so for clustering, so let's say you run a blog, okay? So you run a blog and have a lots of data about your visitors like when they visit, what they read and their interest. So you don't know anything about them, but you are curious to see if they naturally fall into groups. So like uh, one group might be comic book fans who browse your blog in the evening, and another could be sci-fi enthusiast visiting on weekends. So using clustering algorithm like k-mean, db scan, um, K-mean DB scan or hierarchy clustering. The system can sort these visitors into groups based on pattern in their behavior, all without needing you to tell it who belongs where. Okay, it's like discovering tribes among your readers. So sometimes data is too much complex and it feels like looking in tangled web. So visualization algorithm like TSNE or PCA come to the rescue. So imagine they take all the messy data and create a simplified 2D or 3D map. You can easily understand highlighting patterns you never notice. So you might see a cluster of animals grouped separately from a dataset o- vehicle in a dataset about objects. So, or you might reduce data complexity by combining related feature like merging a car mileage and age into a single feature representing its wear and tear. Okay, so dimensionality reduction is like decluttering a packed suitcase. Simplify what's inside without losing the essential. So yet another unsupervised task is anomaly detection. So now imagine you are running a bank and you want to catch fraudulent credit card transaction. So most transactions are normal, but a few might stand out as suspicious. Okay, so they can spot anything unusual like a sudden purchase of expensive jewelry in a far off country. So recently you are just like I gave you an example. You are in India in before 1 hour, uh, and next time after a few minutes your transaction in some out of the India. So this is a one anomaly detection pattern. So so you can suddenly purchase an expensive jewelry in a far off country. Okay. So similarly, type A one of a novelty detection. So focus on identifying entirely new pattern the system has not seen before. So it's like training a guard dog to recognize anything out of the ordinary and sound the alarm. Okay, so what is associate learning? So let's move to the supermarket. Okay, so imagine analyzing sales data and discovering that customer who buy barbecue sauce and chips often buy stick too. So that's association rule, and finding hidden connection. Okay, it's like finding connection in your data. Arm while this knowledge, you could place these items together on shelves to boost your sales. So now talk about the so before talking about the semi-supervised, I talk about also one something more on unsupervised. So making unsupervised learning is not about getting answer help to you. It's about letting the system explore and uncover pattern, grouping, or outlier. So it's like handling the system a magnifying glass to find the story hidden in your data. So by using clustering, visualization, anomaly detection, you can reveal in inside and trends that would otherwise remain invisible. So turning raw data into actionable understanding. And now we are talking about the semi-supervised learning. So some algorithms can deal with partially labeled training data, usually a lot of unlabeled data and a little bit of labeled data. So this is called semi-supervised learning. So imagine you are sorting through a box of old family photos. So some pictures have names written on the back, but most of the don't. So and you recognize some familiar face but need a little help figure out who is who. So this is where semi-supervised learning steps in a perfect mix of detecting work and helping hand. So we can see in Google Photos in our daily life. So when we give a photo name uh, and it's automatic uh, create a group for same person, and when it does not detect, and sometimes it's ask is it a same person or not. So you give again it's the same yes or no. So like that a family photo album story. So let's you upload a photo to a service Google Photo. So the system automatic organize your picture based on who appears in them. So this part is unsupervised learning. So the system spot pattern in the face but does not know who they belong to it. So sometimes it's ask you for a little help. How can you tell me who this is in just this photo? So you label that person as a mom, father. So and the system use this small bit of information to identify her in every other photo she or he appears. So that's the supervised learning part. And what is the reinforcement learning? So reinforcement learning is a very different beast. Okay, so I give you an example imagine you are training a dog to fetch a ball. So at the first, so dog doesn't know what to do. It might run around, sniff thinking things or sit and look confused. But every time it brings the ball back, you reward it with a treat. So over time, the dog learns that phase. The ball gets it treats, so it's better at doing it. So this is the essence of reinforcement learning. Just like in giving this a picture. So the robot uh, gave me choose a action. So one side is bucket, one side is fire. So when it's goes to a fire directly fire without going to a bucket, so it's given a penalty term. It's a minus 50 points. So it's showing the next time it's avoided. So it doesn't go directly to the fire. So when and the robot goes first put the bucket and fill the water and then goes to the fire. So it's give with the reward. And online learning. Okay, so imagine teaching a group of students. Some learn best when you give them all the material at once and let them study until they are ready for a test. Okay, and other prefer learning bit by bit, tackling new challenges as they come. These two styles represent batch learning and online learning. So, like what is batch learning? It's like a bulk learner. Okay, so you gather all the material at once, textbook, notes, videos, and spend big uh, studying. Okay, so once you are ready, you sit for the test and use what you have learned. After that, no more learning. You just apply your knowledge. So, so just like the machine learning is uh, batch learning. So they trained on a complete data set on offline. Okay, so once they trained, they don't learn anything new. They just do their job based on what they learn already know. So example so spam filter that blocks unwanted emails. So if new is types of spam emerges, you can't just tweak the filter. Instead, so all the you retrain all the old data plus the new spam example. So this can be time consuming, costly, and heavy if you have a ton of data. And in the real scenario, in the most of the time we having a tons of data. So the challenges of this batch learning is it's a slow to adopt and resource intensive. Okay, so the training and lots of data is require a lot of computing power, CPU, memory space, disk space, network, IO, etc. And there is a lot of changes, like 20, if there is any changes in 24 hour, so we train our model in every 24 hour. And other one is online learning. So it's like it's always adopting a new approach. So, n- is the so it's always learning. Okay, so so think on online learning like teaching a teacher giving a wide size lesson each day. So the student learn a little every day and applies it immediately. So the way they adapt quickly to new material without needing to restudy everything they already know. Okay, so in the the batch learning or something, when new data comes, we train our model into the old one and as well as a new one. So in this process, we don't need to train every second. So they learn incrementally. In the online learning, they learn incrementally, process new data as it arrives. So each data is and efficient, allowing the system adapt in real time. So when we are using the online learning, uh, so in the stock price prediction, we are using an online learning. So what is the advantage? So it's a real-time adaptability, efficient of use of resources. So and the main problem is the learning rate. Okay, so how fast they should adapt the changing data. So if the learning rate adapt too quickly, so it might forget the old data. Okay, and uh, if it adapt too slowly, so it might lag behind rapid changes in the data. So there is the problem. And one more thing is it's a bad data. So if the data fed to the system bad and misleading data, so it can start making It can start making poor decisions. So that's why constant monitoring is required and safeguard to essential for online learning. Okay, so instance based versus model based learning. So I tell you a story like imagine you are a new chef trying to create the perfect pasta dish. Okay, so you have tasted dishes from around the world and want to recreate the flavors in your kitchen. So how do you go about it? So you have to main approach via learning by example or learning by understanding the process. So what is instance based learning? So it's like you copying your grandma recipe. So let's say your grandma makes the best pasta you ever tasted. Okay, so instead of experimenting, you memorizing her recipe exactly as she makes it. So the same ingredients, measurement, and even the she stir the pots. So whenever someone asks you to make pasta, you simply recreate her exact dish. So now imagine your friend like spicy food. So to accommodate their taste, you look at recipes similar to grandma's but with extra spices. Okay, so you find a balance by comparing various spicy pasta recipes to hers, adjusting slighting based on how similar they feel to grandma's original. So this approach, relying on example and tweaking based on similarity, is instance-based learning. Okay. So in the world of machine learning, this would be like storing you every example in memory and comparing new inputs against those examples. So like a spam filter flags an email. If it's very similar to the previous flagged spam email, so it's effective when the new situation closely resembles something you have seen before. Okay, so this is instance based learning. And what is model based learning? So like so think like you are you becoming the master chef. So now imagine you are tired of copying grandma's recipe and want to create your own. So you observing the pattern. Okay, you observing the pattern and you notice that the more garlic you added, the tastier the sauce becomes. Okay, you learn like that pasta quality improves with a longer boil time. So you write down rules and create a model. So like for every gram of garlic, the dish improves by 5% or 10%. Okay, so you can now predict how good your pasta will taste before even cooking it. So this is the approach, building a model to understand the process and make prediction. So it is a model based learning. So in machine learning, so this is like a creating a formula or mathematical model based on your data. So you could analyze data on your pupils happiness and their income. So using this data you find the happiness increase linearly with income. Okay, happiness increase with linearly with income. So using this data you find the happiness increase linearly with income and you create a formula to predict happiness for any incoming level. So once the model is trained, so this model can predict happiness even for people whose data you have never seen before. So, like you can say, so instance-based learning is like being a good mimic. You learn specific examples and compare new scenario to them. So, meanwhile, what is model-based learning is like becoming a scientist. You find pattern, build a theory, and use it to predict the future. But both approach can work, but they sign in different situations. Okay, so if your environment change frequently, so that time instance based learning can adapt quickly by memorizing new example. But if you want a deeper understanding and scalability, model based learning lets you generalize and predict with fewer examples. So, whether you are making a grandpa recipe or creating your signature pasta, so you are using the same fundamental principle as a machine learning system. So, choose the approach that best suit for your goals. Is it instance based or model based? So, that's all for today's video. Chapter 1 will continue in the next episodes. So, stay tuned. If you enjoyed this, don't forget to like, share, and subscribe to the channel. Drop a comment below. I'd love to hear your thoughts. Thanks for watching, and I'll see you in the next one.